Today's agenda is I will start off with an introduction to the MQTT protocol, just a high-level one. It's not that known a protocol like other protocols like HTTP or AMQP, but it's a pretty good protocol. And then I will introduce a client that I've built that's called Tortoise, and then I will talk a bit about how I'm progressing in converting it to support MQTT 5, which is the new version of the protocol. So, introducing MQTT. MQTT is a lightweight PubSub protocol primarily used for machine-to-machine communication. So, it is designed to run on small constrained devices, constrained in network might be unavailable for short amount of times, and the devices might not be that powerful. So it is it's made to basically run on a temperature sensor, for instance, where the temperature sensor can send a temperature metric to a server. We can have a bus that sends its location data to a server. We can send a command to a lamp, for instance, like turn on, turn off. We can like run it on computers, and we can run it on tea kettles. So how does it work? To make it as simple as possible for a small device, we have a client-server architecture. So MQTT is sitting in the middle. Every device is connected to the MQTT server. So this means that clients cannot see each other directly. So if we want to send a message from the computer to the kettle, like tea time, I moved to London, so we drink tea. And we want to communicate with our kettle that it's tea time. We send a message into the broker, and the kettle will listen for a topic and get the message that way. So it's all based on topics and topic filters. There's a slight difference in these two terminologies, and I will describe these. So here in my handy example, I have a building where it has a couple of floors: first floor, second floor, and third floor. And on each of the floors, we have a temperature sensor and a lumen sensor, like a brightness sensor. And let's look at one of these devices. The temperature sensor will send a publish message to the broker where it has a topic. So the payload is 21 degrees here, for instance. The topic is split up. It has a structure. So it has topic levels separated by slashes when we read them. And here I have a building and a floor number and the sensor type. The way that you choose to construct your topology is up to you. Like it's a free fall depending on the configuration of the server. So feel free to create your own topic structures. Here I have this one. So when they publish to a topic. But when we subscribe, there's a different semantic, because, for instance, if we subscribe to this topic, it's a specific topic. So in this case, we would only hit this one. Right. We can, in topic filters, we can use single level wildcards. So if we did this in our building example here, we can choose to match on all the floors, and in this case we would hit all the temperature sensors in the building. If we chose to set the topic level filter in the last part here, we would get all the sensors on second floor. And of course we can have multiple topic level in one topic filter. So this would basically get us all. So get us all the topics in the building. So we also have a multi-level wildcard, and of course this works like this. It will match all the topics beneath. Right. So a topic is used in a publish, and a topic filter is used in a subscription. So besides that, we have a concept of a quality of service in this protocol, and we have 3 of them. The first one is QoS 0, and that means at most once delivery. QoS 1 means at least once, and QoS 2 means only once delivery. And how do we achieve that? Well, for QoS 0, the at most once delivery, we just send the message, and there's no reply back from the server. It just there's no delivery guarantees on this, so we can have a sensor that just shoots messages and nobody receives it. This is kind of like a gen server cast. It can be used for instance, a temperature sensor where we send every second, and we don't necessarily need every second to be recorded. Just some of them. So if we need some delivery guarantees, we can use QoS 1, at least once delivery, and that in that mode we have a correlation ID, which the server will respond with a pop-back with the same correlation ID. So when we receive the pop-back, we can reuse the ID. So if our computer sends the message twice and receives the ARC, then we could end up in a situation where the same message is sent twice. So that's why we have QoS 2, which implements only once delivery. And this works by, again, we have a correlation ID and correlation ID. And then we receive a pub receive, which basically the MQTT server tells us that the message has been received. At this point, we would stop sending the publish, and we would then send that we have received that they have received it by sending, okay, we're going to release this message. And then we will receive a pub complete, signifying that the server is okay that we have ended the transmission. And this creates a serialization point. So, of course, the higher QoS that you use in a message, more messages will be sent on a wire. So always pick the lowest you can get away with, depending on your needs. And of course, it's per publish. So you don't have to choose one for all. You can mix and match. So in short, a client can do the following to a MQTT server. We can of course connect to it, and we can publish messages. We can subscribe to topic filters. We can unsubscribe from topic filters, and we can ping it, and we can disconnect. And it sure would be neat if somebody had built a good client for it, for Elixir, and somebody has. It's me. It is an MQTT client with a cute logo, and the logo was designed by my Twitter friend Laszlo, and he's up there. So I'll just take a moment to take a sip of water while you can pull out your iPhones and follow him. And we're back. Yeah. So let's talk about what a client for a network protocol should do. And I think that a client should allow you to do everything that the spec allows you to do. Like we should basically implement it all. Like and me as an author, I should keep my opinions out of it. Like if the protocol defines something that I don't necessarily agree to, I should keep that to myself and just implement it, because like my users would expect the features from the protocol to be in the client. So, but I can provide defaults, and I can automate things. So stuff that just needs to happen, like handshakes and stuff. I can automate that. The user doesn't need to be included in that. Things that only has one way of happening can happen automatically. Okay. So in other ways, a client should hide the protocol details that can be hidden from the user without limiting the user in what they want to do. So we need to find the intersection between Elixir and MQTT. So in other words, we need to map Elixir semantics to MQTT semantics and figure out the stuff that can happen behind the scenes. And furthermore, we got two semantics for client. We got the outgoing messages and we got the incoming data that we need to handle. And these two semantics are not necessarily the same. So let's first talk about the outgoing messages, the ones that are initialized by us. So to understand how we do stuff in Elixir and Erlang, for that matter, we got message passing and we got processes. And processes, they have an identity. And we have a method for sending. So once we have an identity, we can send messages to that process that has that identity. And this is a great way of doing things. Like this is why we like this language. So Tortoise is an application that sits between you running in that process and the MQTT broker. So for us to make a good client, we need to shoot messages into the MQTT client, and then we have that mitigate the communication between you and the client, such that it seems to you as you're working with Elixir and not just MQTT. So there's a mapping between the two semantics. So to handle identity, we got in the MQTT protocol have a concept of a client ID. So I've chosen to adopt that, and this is how we start a connection. These are the minimal data that you need to provide, the minimal configuration you need to provide to the start link to start a connection. So the client ID, we pass that in, and this is now our identity for that connection. You can have multiple connections. This is kind of like using process register to register the name for a process. So at this point, client ID will now just be toes. So we define a topic, which is a string, the OCP tower, third level temperature, and then we define the payload, and then we just use publish, like we would with kernel send. And yeah, we can specify options with an option list. So quas 0, how would that work behind the scenes? We so when you run the Tortoise publish for with a quas 0, we will request a network socket, and then the Tortoise application will respond with that network socket, and then in our process we will encode the message to the MQTT format, and then we will send it directly. Like this is the fastest way. We basically just shoot directly into the TCP socket, and we can get away with this because we have no delivery guarantees. But for quas 1, we create a reference, and then we send the publish into Tortoise with that reference. So we have the makeref, the reference coming out of makeref is native to Elixir. So this is Elixir semantics. and then Tortoise will send a message, send our message to the broker with the correlation ID that is native to MQTT, and then we will send back the response like this. And basically, this is the same semantics for Quas 2, just a bit more work for Tortoise to do to fulfill the Quas 2. So, if we look at the things that the data we will receive from Tortoise when it completes a message, a publish with a Quas above 0, 1 or 2, it will look like this. We will get the it's namespaced with Tortoise, and it's namespaced with the client ID. So you can have multiple client IDs for one process. Connected, multiple connections with multiple client IDs for one process. And we have the reference, which was the one we made with makeref, and then we have the result. And by doing this, we can basically implement our own receive semantics, right? So here I make a selective receive, and I can specify a timeout, and like you would expect from an Elixir application. So basically, Tortoise has the following outbound API. So we can connect with start link, and we can publish with just Tortoise publish, and we can connect. We can subscribe with and unsubscribe, and we can ping the broker if we really want to. It actually happens behind the scene because it's just you need to send a keep alive message once in a while if you don't send any other messages, and of course we can disconnect. So this maps perfectly to what you would expect from an MQTT client. So handling incoming messages, and the insight here is that a connection has a life cycle, of course. So life cycles. Any life cycle that we know from Elixir and Erlang already, well, of course, the gen server. So the gen server is basically a receive loop, and we just receive until we eventually terminate. And to get into the receive loop, of course, we have an initialized state. So this is all well and good, and we know about this already. So for the Tortoise handler, like how would we do that? Well, once we're connected to the broker, we have a receive loop, and we handle the messages that that we subscribe to, like incoming, and we do so until we reach the terminate phase, and then we have our init. But this is basically a gen server. What's up here? Like we actually have a connection phase as well. So so this is the life cycle of a Tortoise connection. Of course, in the connection, we just because we're kicked off the broker doesn't mean that our connection or a session is dead. We can log on to that session again. So here's the main difference. Like we can fall back to the connection state. So the callbacks that I have chosen for this is the init, and I have a connection callback where you have a status that you can match on, saying up or down, and we have a state, we have a loop state that we can store data in depending on our needs, and this allows us to make a lamp red or green depending on the connection state on a Nerves device. And then we have the subscription where we can, for the individual topic filter, we can say up or down. So when we subscribe to a subscription, then we get an up message for that topic filter. And we have handle message. When we receive a message from one of our subscriptions, then it looks like this. And of course, we got the terminate, like you would expect from any good OTP behavior. So let's look a bit at the handle message, because I have written topic list. What's up with that? It's basically because lists are better for pattern matching than a string. Like we would know to we would need to, like, there's simply no way to pattern match on a binary and make it like a list is just, if we split it on the topic level separators, then we will get a list, and we can do pattern matches like this, like this semantic maps to this semantic. And it gets even better because the multiple level we have a syntax for that as well. So lists maps perfectly well to the topic semantics in MQTT. So in code, it would look like this. When we handle an incoming message, we could store the building and the floor in a variable and use it in our business logic. And we can, of course, because it's pattern matching, we can match on literals. And we get the payload. So this is a pretty good interface for handling MQTT. And MQTT 5, I really like that interface. I hope there's no big changes that will destroy all this. So let's talk about MQTT 5. Here's a slide with some of the new features. There's session expiry and there's message expiry, such that we can say to a publish that if it's not delivered in 200 milliseconds, just disregard it. We have more verbose error messages. This is really good because now I can tell my users why we got kicked off the broker. Like, if the broker does not support Quest2 and we send a Quest2, it will kick us off, and now we will actually know why. That's good. And there's some capability negotiation on Connect, so we can, the server can specify that it only handles message under 500 kilobytes, for instance. And there's some formalization of some of the community patterns that has developed over the years, such as RPCs and shared subscriptions. And then we have enhanced authorization and user-defined properties, which are pretty good, and much more. So let's talk about enhanced authorization. This is the previous semantics for our handler. We now got a new phase. So we got an auth phase where we in our connection can go into this extended authentication, and we will loop until, like, it's more than just a challenge response, challenge reply. Like, you can basically with this model any kind of authorization that you want to, and of course we can end up in the terminate state from there or into the receive loop. So this is a pretty good change, and this is pretty easy to implement. So user-defined properties. These are also pretty good because now we can put some extra data on our published messages, for instance. So the temperature sensor on the 3rd floor of the Nakatomi Plaza. We can specify a sensor ID, for instance, such that we can see if there's one of the temperature sensors that are like slightly off, we can see that it's that one in this case, and we can tell it that we're using Celsius, the thing that I understand, and this is pretty good because we just publish with the properties, and the MQTT server will send it opaquely to, like, it treated as an opaque thing that it just sends to the other clients connected to the server, listening on that topic. It's pretty good. So when handling messages in the current version of Tortoise, we just have a payload, which is the binary. But for the new one, I need to expose the my internal data structure. And this is not the biggest problem because you can just access the payload like .payload, and you can now access the new properties by saying .properties. So this is pretty cool. That's pretty good. There's really no big deal. Like, it's pretty easy to shoehorn into the current implementation. But there's some trouble because of some and I shouted a bit about this while they were doing it, but nobody listened. So my new problem is that these protocol, like other protocol packages, has user-defined properties. So this is the MSC for the Quest 2 that we shown before. So if we focus on this part, what's happening between the Tortoise and the MQTT, now we basically have properties on all the protocol packages, and this means that we need to expose these to the end user, because there might be something in the properties for the pub_rec, for instance, or the pub_comp that the user would like to hear about. So we need to specify a way to handle that. And if we look back at the rules that are set up for myself for developing this client, that a client should allow everything that the protocol allows, and I should keep my opinions out of it, and I can hide things that can be automated. Like if I just disregard the 2 first rules and go with my 3rd rule, then I wouldn't be true to myself, and I wouldn't be able to sleep at night. So previously, like, I need to change the API a bit to comply with this, or allow the user to peep into these bookkeeping packages. So this was the previous interface. I've changed this just a bit to expose a bit more. So now it's like this. For instance, now I have a handle pub_comp where you get access to the pub_comp message, and this is not the biggest deal in the world, because most of these can be I can implement default behavior for them, but it's kind of annoying that I need to actually expose all this data to the user, because I cannot dream up a reason that you would like the pub_rel, for instance. What do you need the user-defined properties, and what can they contain actually? And I think there's some MQTT experts in the audience who can inform me on what we will actually use this feature for. But yeah, so the conclusion is Tortoise for MQTT 3.1.1 is ready today, and I haven't put the 1.0 version on it now, but there's people who are using Tortoise in production now, and I know at least 2 American companies using nerves, making nerves devices to use Tortoise. And MQTT 5 will cause some changes to the API, and MQTT 5 support is in a branch, and it kind of works, but it kind of still needs some work to be solid. And the Tortoise will drift towards a low-level API in the future to support everything. But this is also kind of interesting, because now Tortoise becomes a low-level API that you can use to create your own UX on top of. So you can build your own MQTT client by using my engine in the background. And once again, this is the logo. This is where I currently store the code. There's a MQTT 5 branch if you want to play with it. It's kind of like, it's getting there. I'm working on it once in a while. And once again, the logo is made by Laszlo, and you have another chance of following him on Twitter. He's pretty good. He's doing design for, like, he's doing this Hanna-Barbera style graphics, and he is doing 8-bit graphics as well, and he's retreating all kind of indie game development. So yeah, any questions? Does Tortoise support MQTT SN, the Sensory Network version of MQTT? I have actually not looked too much into that protocol, but I know it exists, and I don't support it in Tortoise right now. But like, I don't know if that would be another library, because it seems simpler, even simpler, and it's designed to live on one of these devices that are hibernating most of the time, then waking up and make a connection and send one metric in, and then go back to hibernation. Is that a good, like, I think you are MQTT people, aren't you? Yeah. Yeah.
I'm interested in how you implemented the on-wire format, bits and bytes encoding, decoding code. Is
Um,
there any code generator, or did you handcraft them?
I handcrafted it. Yeah, I have a yeah. We can do it code if you want to.
Great talk, Martin.
Thank you.
We just heard a good talk from Valentin as well on how they're exploiting UDP.
Hmm.
So, how easy would it be to make the transport configurable? So, if you want to use MQTT over TCP, use that, or just switch to UDP.
I have an abstraction for the transport, but I don't. Let's see. UDP would
Gen UDP, I guess.
and the protocol only supports transport that has framing already and all that good stuff.
Sorry.
Um,
Okay.
I,
So it's
I,
because we just heard another talk where they're exploiting UDP
yeah.
and making UDP do things which we didn't think would be possible.
I have an abstraction for it, and
Okay.
that's to eventually support WebSockets.
Okay.
But that has all this framing and delivery guarantees. But it could be a fun experiment to see if we could get it working.
Your QoS will be effective, not all will be supported.
Not all. No.
Thank you, Martin.